Good morning, my dear students. In this chapter electrolysis, so far we have studied. In our last class we had seen oxidation and reduction. Today we will proceed with the chapter Theory of Electrolytic Dissociation. This theory was given by Arrhenius. According to Arrhenius, during the electrolysis, an electrolyte, when it is dissolved in water, they dissociate and form free mobile ions, means they produces positive ions as well as negative ions, and these ions are responsible for the movement of the electric current. When this sodium chloride is added in water, they dissociate to form sodium ion and chloride ion, and these ions are responsible for passing the electric current. All ions carry positive charge. All ions means, like suppose you had given the example of sodium chloride, then after dissociation they contain sodium ion and chloride ion, which are responsible for the passage of current. The conductivity of electrolyte depends on the concentration of ions, means more are the ions, more is the dissociation, more ions will be formed and more will be the passage of electric current. During electrolysis, number of positive ions are equal to the number of negative ions. If we see, if sodium will 1 electron, chlorine will get 1 electron. If sodium loses 1 electron, chlorine will also get 1 electron. So number of electron lost, it is equal to number of electron gains. That is the why we say, in other words, that number of chlorine, number of positive ion, it is equals to the number of negative ions. But what is non-electrolyte? The substance which do not allow electricity to pass through it, even in aqueous or molten state. Why? They do not dissociate, neither they dissociates, and if they don't dissociate, no ions will be formed, means they will remain in molecules. So in electrolytes there are no free electrons and they do not pass electric current. Sugar, benzene, alcohol, these are the examples of non-electrolyte. Then degree of dissociation is the extent to which an electrolytic dissociation or breaks up into ion. Degree of dissociation. Degree of dissociations. What is degree of dissociation? We have seen this is degree of dissociation. What are the ions formed? It is ions formed by total number of molecules present in 200. What is the number of molecules present in the solution? And what number of molecules have ionized, dissociated into 100? It is called degree of dissociation. This theory was given This theory was given by Svante Arrhenius. But there is a difference between Svante Arrhenius and modern concept. What does modern concept and Svante Arrhenius says? According to Svante Arrhenius, water ionizes the electrolytes. Water dissociates means when an electrolyte is dissolved in water, the electrolyte dissociates and form positive and negative ion. Modern concept also says that even in the solid state, they are ionic, but due to the strong force of attraction, the opposite charges are held together with a strong electrostatic force, due to that strong electrostatic force, they are not in a condition, the ions are not in a condition to move. For example, when sodium loses one electron, it forms sodium ion, and this lost electron is gained by chlorine and forms chloride ion. So these opposite charges attract each other and form sodium chloride. In this sodium chloride, this sodium ion and chloride ion are held together with a strong electrostatic force, due to which these ions are immovable. This concept is given by modern concept. Now, conduction in compound. Conduction in compound, all the electrovalent compounds, they conduct electricity only in aqueous or molten state, because in dry or in anhydrous state, they do not conduct electricity because the ions are not in a position to move. But when they are in molten state or when they are dissolved in water, these ions, this force of attraction becomes weak, and the positive and negative ions, now they are in a position to move and they conduct electricity. We will see this after a few minutes, how and why the ions dissolve in water, or when it is infused, they conduct electricity. Then, what is the characteristic of electrolysis? The passage of electricity through an electrolyte causes positive ion. Positive ion. During electrolysis, the compound dissociates and they form positive and negative ion. These positive ions migrate towards the cathode, and negative ions, they migrate towards the anode. What happens? In my first class or second period, I had told you this cathode is the reservoir of electrons. Now, if this sodium has lost its electron, this will migrate, sodium ion will migrate towards cathode. Here, cathode will provide the number of electron or number of electrons lost. Sodium has lost one electron, so at cathode, sodium ion will gain one electron and form sodium, neutral sodium. This chloride ion will migrate towards anode. How this chloride ion has formed? By gaining one electron. So this chloride ion will lose the one electron and it will form neutral chlorine. So during the electrolysis, positively charged means ions means cations migrate towards cathode, anions migrate towards anode. I had given you the concept that CC means cathode toward cations toward cathode, AA means anions towards anode. So all the ions carry electrical charge. If they are cations, they carry positive charge. If they are anions, they carry negative charge. And these charges are responsible for the flow of electric current in the solution. The conductivity of electrolyte depends upon the number of ions, concentration of ions, amount of ions present in the solution. Less is the concentration of ions, less will be the flow of electron, and if more is the concentration of ion, more will be the flow of current. The number of positive charge will be always equal to the number of negative charge to maintain the solution in an equilibrium state. ऐसा नहीं है कि 11 हो गया पॉजिटिव चार्ज तो 12 हो जाएगा नेगेटिव चार्ज और 10 हो जाएगा नेगेटिव चार्ज. नो, इफ द नंबर ऑफ पॉजिटिव चार्ज इज 11, the number of negative charge will be also 11 only, so that the solution will maintain the equilibrium state. In non-electrolytes, only hydrogen gas and metals are liberated at cathode. Means liberated at cathode means only hydrogen and metals can lose electrons and they will migrate towards cathode. They will gain electrons from the cathode and they are discharged at cathode. But non-metals, they are also called electronegative elements. They all gains electron and they will migrate towards anode and they discharge at anode. They lose their electrons. Whatsoever they have gained will lose at anode. And the mass of substance produced at electrodes, whether it is cathode or anode, whatsoever mass is produced at the electrodes during this electrolysis, it is directly proportional to the quantity, directly proportional to the amount of electricity passing through the electrolyte. Higher is the electricity passed, higher will be the mass obtained at the electrodes. This law was given by Michael Faraday, which we will study in class 11. Michael Faraday's law of electrolysis. Now during this process means during electrolysis, oxidation and reduction takes place. How? See, sodium chloride, after dissociation it forms sodium ion and chloride ion. Just right now we had seen that this positive ion migrates towards, this cation migrates towards cathode, and at cathode they gain electron and become neutral sodium. Then what is reduction? Gain of electrons. So this ion, cation, gains electron at cathode and gets reduced. And what happens at anode? This chloride ion, how it has formed? By gaining electrons. So it will lose electron at anode and becomes neutral chlorine ion. So what is oxidation? Loss of electrons. So two atoms of chlorine combines together and form one molecule of chlorine. So what will be the overall reactions after this sodium chloride? After dissociation, it forms sodium and chloride. For this electrolysis process, we normally use DC current because alternating current does not cause any chemical change when passed an electrolyte, and therefore they does not help in the process of electrolysis. Or there are many other reasons why we don't use AC current, why we use only DC current. We will see in this chapter after one or two classes. So for the electrolysis we use only DC current. There will be two topics. One will be electrolytic dissociation, another one will be ionization. In both the cases there are the dissociation of compound. In both the cases, electrolytic dissociation and ionization, compounds will be dissociated, but there is difference. In this process, electrovalent compounds will dissociate when they are fused or they are dissolved in water, but in ionization, polar covalent compounds will dissociate. So the process due to which an ionic compound, electrovalent compound, dissociates into ion in fused state, molten state, or in aqueous state, aqueous solution, aqueous state. This dissociation of electrovalent compound in aqueous or molten state is called electrolytic dissociation. My dear friends, dry sodium chloride, they do not conduct electricity. Many times this question has been asked in our board exam, why dry sodium chloride does not, or even sometimes we are asked why solid sodium chloride does not conduct electricity. Our answer is very simple. Sodium chloride, it is an ionic compound. Its structure, crystal structure, contains sodium ion and chloride ion. After losing electron, sodium becomes positively charged, and after gaining electron, chlorine becomes negatively charged, and both these opposite charges are held together with a strong electrostatic force. As a result, the ions are not in a position to move. But when the sodium chloride is dissolved in water, or they are strongly heated, when they are in the molten or fused state, what happens? This force of attraction between the sodium ion and chloride ion becomes weak. The ions becomes weak, and now the force of attraction is weak or almost negligible. As a result, these electrons are in a position to move. So in the aqueous solution, the slightly negatively charged oxygen atom of polar covalent, see water, it is called polar covalent. So the force of attraction becomes less and the electrons are in a position to move. Then ionization. Just right now I had told you that in electrolytic dissociation, ionic compounds dissociates, and in ionization, the polar covalent compounds dissociates. Not all the covalents but certain covalent compounds, certain covalent molecules which are not made up of ions. Covalent compounds are made up how? By sharing of electrons. So there is no ion formation, but certain covalent compounds form ions. They form ions when they are dissolved in water. This solution contains conduct electricity. So now what is ionization? The process by which certain, not all, very few, so certain polar covalent compounds are converted into ions, are dissociated into ions when they are dissolved in water, are called ionization. For example, we know that all the gases are poor conductor of electricity. All the gases are non-conductor. Likewise, in the gaseous state or in the pure liquid state, means when this hydrogen chloride gas is compressed, it will change into liquid state. We know that gases after compression, they are changed into liquid state. So even in the liquid state, this hydrogen chloride will not conduct electricity, but now it is polar covalent compound, polar covalent in nature. Once again, I would like to remind you what is polar covalent bond. First, what is bond? The bond formed between two atoms having large electronegativity difference. In the periodic table, in page number 13, I think, Linus Pauling has given a concept that what is electronegativity? Tendency to attract the shared pair of electrons. Suppose hydrogen and chlorine shares one electron each, so it should lie in between. But the electronegativity value of hydrogen is 2.1 and that of chlorine is 3. So this shared pair of electron will shift slightly towards chlorine. As a result, here is a symbol like this. This means slight, very less. It will be slightly positively charged and this one will be slightly negatively charged. And this hydrogen, here is one in water. There is two lone pair of electrons. So this hydrogen ion or this proton combines here and form with water and forms hydronium ion. So certain covalent compounds, when it is dissolved in water, it dissociates and it forms hydronium ion. We should know the difference. First difference is what? Formation of positive or negative charge ions. They form, they ionize. Cup. Formation of positively or negatively charged ions from molecules which are not initially in ionic state. They are not in ionic states. They don't form ions. They are not formed by ions. They are formed by molecules, but they ionize when dissolved in water. And this is separation of ions. For example, sodium chloride, it is already formed by the sodium and chloride ions. Now they are separated by this dissociation, means electrolytic dissociation. Polar covalent bonds or polar covalent compounds, they ionize. Here are some examples. After dissociation, this forms hydrogen ion and chloride ion. This ammonium hydroxide will form ammonium ion and hydroxyl ion. But here electroviolent compounds get dissociated. Electroviolent or ionic compounds gets dissociated. So my dear students, it was for today. We will start the next topic in the next classes. Wish you all the best. Goodbye.